I have a second channel, Cube Comp MTDX. Hey everybody, here we have another laptop battery we're going to disassemble. This is a Toshiba pack. See if I can figure out the year it's from. Sometimes you can easily tell, sometimes you can't. I'm going to say from 2009 to 2011, that time period. It's got Panasonic cells. It's a 6-cell pack. Capacity total for this pack is 1400 milliamp hours, so we're working with probably 2200 milliamp hour cells. I rarely ever see packs labeled as 4400 milliamp hours. So it's a 3S 2P pack. So we're going to see if we can get into this thing. The thing is, these packs are built really well, many of them are, and that are thus more difficult to get into. Okay, so this pack does not have any holes under the label, so that's not going to do us any good tearing that off. So if this is your first time dealing with laptop batteries, if you're wanting to harvest the 18650 out of them, I should mention that when you go to tear one of these apart, you gotta be really careful, because of course these cells are still hold a charge, and if you insert your screwdriver or tool into the wrong spot, let's say this is positive up here, be inserted in here, and you could potentially short out a cell. And you also have conductors running throughout here, because these cells they're hooked up in a not only do you have them all the cells hooked together to get your total voltage, but you also have wires hooked between the banks, more or less, for balanced charging. So you gotta watch out for that too. So we're gonna figure out how to get into this thing. This isn't my first. This isn't the first time I've disassembled a Toshiba pack. I think I've disassembled probably 3 or 4 of them in the past. And the thing with me is, I take my time on these things. There's some people who just rip them apart real quickly, but I prefer to take my time a little bit, so that way I have a lower chance of accidentally causing a problem. So what I'm doing now is I'm just trying to locate a weak spot in the pack. And once you have an idea of which side is positive, which side is negative, for example, let's say if this side is negative, you can safely work around in here on this side, because of course this side is negative, but this side over here is positive. And the thing about it is 18650s. For example, this one here, you can see right here is positive, but right over here is negative. It's really close. So I'm going to probably be editing out some parts of this video, or at least speeding it up. So sit back, relax, and have fun as you watch me tear this thing apart. Okay, so I think I found some weak parts in this pack, and I'm just using this X-Acto knife to try to work my way in. Now, as I mentioned, if this is your first pack you're tearing apart, chances are you're not going to have 18650s laying around. But what you could do is, if you do, you could just lay them like this to try to gauge where the individual cells are located, and try to, of course, if you're sticking your X-Acto knife in, you got to be really careful. And also, you don't want to damage. You want to try to not damage the cell wrappings too, but those can be replaced. Rewrapping a cell is actually pretty easy. Okay, so I've managed to breach into the pack. I'm just using my screwdriver to try to prop this open here, and I can see one of the cells. And the cells are light green in color, kind of like my Panasonic NCR. What are they called? NCR 18650Bs. Of course, these are not the same as what's in here. Different capacity. I should note it's important to keep a watch on the temperature of the pack, because if you short out a cell, obviously it'll get hot real quick. And I'm just using the knife to gradually work my way down the side here. Also being careful to make sure that I'm keeping the blade of the knife away from any metal contacts that are in there. And what this is doing is it's helping to break the sort of the plastic weld that is in there. Okay, now that I've cut through most of this with the with the knife, I'm going to start to pry this open and use a couple of flat blade screwdrivers as props to sort of prop it open. Now, it's important that you don't put a whole lot of leverage on the cells themselves. Although they are made of, I think they're made of steel, you don't want to be putting a lot of pressure on them and risk damaging the cells, because if that happens, it could end up resulting in a venting with flame situation, and you don't want that. That's one of the reasons why these packs are built so rigid. And as you may be able to see, the top part is snapping off little by little. I like it when packs are like this. Once you get a good start, they start popping apart rather easy. And hopefully these cells are still good. So I'm going to start attacking this bottom piece here. Try and break it apart a little bit. It's like, yay, more green Panasonics. Now I just have to make sure I don't confuse these with my existing Panasonic cells that I have, which these do look a little different. They're a different model. So I would not have to look much further than the cell itself to really know that, hey, these are different ones. Again, as mentioned, whenever you're inserting any kind of metal tools into one of these, you gotta be careful to make sure that you don't insert your tool into a metal connection inside the pack. All right, so as I suspected, I believe. Actually, no, hang on. Okay, so positive is over here on this side, negative is over here. So it's important that you look for that as soon as you can, because then you can know how to better attack the pack. Okay guys, so there's a strip of metal right here that runs along the side of the cell. Now while, and of course this piece of metal here is at the same negative potential as this cell, but if you were to be touching here and touching your metal tool up in here and there was a small breach in this wrap, you would actually short out these cells here, so you gotta be careful. Okay, so the way this pack is put together, I'm going to have to actually break out the soldering iron to break these connections loose from this circuit board, because although the farmost connection does have a wire, the rest of them just use these tabs that are soldered right into the PCB. Now, you could probably break those loose with a pair of pliers, but if you have a soldering iron handy, it's better to do it this way. We're just going to have to desolder the connections here. Make sure we're not transferring too much heat into the cell. So what I'm doing is I'm removing some solder from these connections. There's a lot of solder on these too. Make sure we're not, again with the solder iron, we'll make sure that we're not transferring too much heat through that connection and heating up the cell. Okay, so now we should be able to lift up the PCB from the pack. Okay, so that one's now loose. Another thing you should be careful with is when you're dealing with solder, make sure you don't get any loose solder bits around the positive of the cells. Okay, now we like it's this last one over here. In case the camera didn't catch it last time when I said it, while it seems like Toshiba can't seem to make a decent laptop half the time, they sure can make a decent laptop battery. This thing is definitely built like a tank. We gotta be really careful with this one, because if we get that tap too hot, what can happen is it can melt through the insulating material and short that cell out. We don't need that. Now I'm removing these two thermistors, which are just held down by tape. And now we can safely peel that back enough to where we can get at it better. Now I'll just use the soldering iron again to heat up that solder and get this off of here. And if you have trouble heating up the connection, you could actually add some solder back to it and try again. And it's off, finally. Okay, so we're done with the soldering iron. Now we can go ahead and check these cells and see what we're looking at as far as voltages go. And we got this double-sided tape here that we gotta get off. I hate it when they use this stuff. This stuff is such a mess to deal with. it'll be quite fun getting off the cells. When push comes to shove, I could just rewrap them. However, these, they have like a, yeah, it's like some Panasonic cells, they had this coating on them instead of like a cell wrap. It's just kind of weird. Could be a little more challenging to get that off. Let's see what they're holding for voltage. So the whole pack is sitting at 8.82. The first set of cells 3.5. The next cell, the next set is just at 1.8. So this was a pack going bad. And the front cells 3.5. So the centermost cells I'm gonna probably recycle. Now, to be honest, yes, we could revive those. However, I have found that it's generally a waste of time trying to revive cells that are sitting below 2 volts. Now, if the whole pack is sitting around 2 volts, for example, or 2.2 to 2.5, I will put in some effort to try to revive them. However, if they do come now, a set like this, cells like this, these two, if they were to come back, the capacity of them probably wouldn't be all that great. That's because they've been sitting at such a low voltage. The fact that these are so out of balance from the remaining 4 tell me that these are probably going bad anyhow. But in the case of a whole pack sitting kind of low, in that case, yeah, I probably would try to revive them. And in those cases, you generally can get them to come back. So what I'm going to do now is I'm just going to try to break these tabs. Usually can do it by just twisting them back and forth enough times. Now I like how, for example, this pack, I like how they went the extra mile in putting all this extra material in between all the cells and the front of the cells and stuff to try to help insulate the cells instead of just relying on the cell wrap itself to do the job. Okay, I'm getting a little impatient here. Okay, we broke that side loose. Now let's do that side over here. Now, of course, I'm just waiting for somebody to leave a comment talking about my fingernails being long. I purposely had not cut them yet because I have, because they kind of help pry into these packs. I plan on cutting my nails after, like for example after this video, since I believe this will be the last pack I'll be harvesting from for at least a little while. Now I should mention, when you're going in with tools like this, you gotta be careful around here, because if there's any nicks in that cell wrap, you have to keep in mind that your pliers touching this metal up here will be at the same potential as the positive of these cells, and if you touch the negative, that creates a short. So I'm just going to actually twist like this and see if that'll break them loose, and it is. So the center pack, the center portion, I'm going to just I'm going to get rid of those. I don't plan to really do anything with them, considering, again, they're sitting below 2 volts when the rest of them are sitting at a good 3.5. So there you have it. So again, just to check. That's a good pack. That's a good set. These are the bad ones. 1.8. And these last ones over here, to your right, 3.5. So it's very likely that the computer was treating these as treating this pack as a bad pack. And that's all it takes is for one bank of cells to get way out of balance or stop holding a charge, and of course the whole computer will the laptop will say the whole pack is bad. So, in case you ever wondered why some people will harvest 18650s out of supposedly bad laptop batteries, well, that's because all it takes is for one bank to go bad. So I'm going to go ahead and mark these as bad, and I'll resume the video in a moment. Okay, so I'm going to go ahead and separate these cells. And here's a part where you got to be careful. Of course, these tabs are sharp. For one thing, they can cut you if you're not careful. Also, now on the negative side, it's not as big of a deal, but when you're pulling, you just gotta. Well, on the negative side, you gotta be careful when you're pulling these off that you don't puncture the bottoms of the cells. Now, this seems to be more of a thing that happens with power tool batteries, because a lot of times power tool batteries have thicker metal as the conductors. And when I get to the positive, I'll also talk about some things to keep in mind over there. Now, chances are you're not going to get every last little bit of this metal off of the cell. But what you can do in that case is you can either sand the connections down, or here's what I'll do in this case, since I believe we're about as far as we'll get. Sorry if I didn't get that on video. When you're pulling these off, let me readjust this camera a little bit. So when you're pulling these off, again, be careful about, because this metal is very sharp. It also tends to tear a lot. And in some cases, these things, they're spot welded together really well. And with power tool batteries in particular, they use, of course, a thicker metal that will take a lot more effort to get loose. And when you're ripping these off here, you gotta be careful to not puncture the cells, which happens more often with tends to happen more often with power tool packs. And for these leftover pieces, you can just take your pliers or tool and just of course smack the ends. Not really hard, but just enough to flatten that material down. Now, it's nice when it all comes off, but in reality, a lot of times that doesn't happen. And of course, this is a telltale sign that the cells you're working with have been pulled from a pack, like say a laptop pack. Sometimes you'll find this in counterfeit vape cells. And of course, they're in a lot, especially with counterfeit cells in general. What they do is they send them back to China, and they crack them out. They harvest them out of packs, and rewrap them, make them look like they're brand new. Put a false tip on the top and a false tip on the bottom to cover up the nubs. So yeah. Anyways, now that we're on this side, I'm going to talk about the positive. So, similar deal with the positive. Now, with this pack, they do have this insulating material, which I think I talked about earlier. I'm glad that this manufacturer went a little further and actually provided that, instead of relying on just the cell wrap to do the job. Now I'm about to pull this off of here. With the positive you definitely want to take your time a bit more. To use extra care to not short anything out. And we'll do this one now. You see how that was scraping up against the cell wrap? You got to watch out. Because that could scrape into the wrap and actually touch the negative of the cell and cause a short. Now that we have this leftover material, I want to talk about something else. This is actually more important on the positive side of the battery. Is you got to be careful to make sure you don't have any real small bits of metal pop loose. Now these cells, the insulating disc, they're well up against the positive. But for example, with some other cells, a good example would be the Sony cells that I have. You may see that there's a little bit more space in there. Now, last night I rewrapped a few of these cells, and I noticed when I peeled the wrapping off and pulled the black disc off, I noticed there was a really tiny piece of metal just sitting right on top of the last part of the negative, the negative ring around here, and it was really close to touching the positive. I think it was a little piece of metal, couldn't tell for sure. Not sure how it got there. There's a possibility that when I was tearing apart the tabs, maybe a little piece of foreign metal got inside there, or it could have been that way since 2003 when the pack was manufactured from Dell. So if that would have shorted out, we would have hoped and prayed that the cell's built-in CID, or current interrupter device, would have operated to stop the cell from mass destructing or self-destructing. Because while these things don't explode very often, when they do, it's violent. It'll burn your house down. See, you don't want that to happen. So, well, at least I hope you don't. I don't want my house to be burnt down. So you gotta be careful when working with these things. And in case you're wondering, these are considered unprotected cells. Now, they do have the the built-in PTC as well as the CID, which are the two different types of built-in cell protection that you have. But that does not protect the cell against overcharging and over discharging. Now my video cameras, of course, they cut off well before the batteries get too low. But with my flashlights, I gotta kind of have to pay a little bit more close attention. Now, generally with LED flashlights, they will cut off once you get to a certain point. But with unprotected cells, you gotta pay a little bit closer attention. So I'm trying to get the rest of this off of here. I'm gonna probably end up having to smack it down. Let's just do that. Now I would suggest being a bit more gentle when on the positive side of the cell. Now I'm just giving real gentle hits here, so you don't want to like bang the cell real hard. Obviously that will likely cause a problem. Now I may follow up later with some sandpaper to try to remove some of that, or at least try to sand them down. So I think I'm going to actually, I'll actually leave these pieces on there. It's an added safety measure. So go back over to this other one. Try to remove some material. Okay, so I'll repeat these steps with the second bank and I'll resume video. Okay, so I got all the cells freed up from the metal tabs. I did end up going ahead and removing those insulating discs off the tops because one of them, or actually I think two of them, they were actually going over to the side too, where that tab on the side used to be. And also, I wanted to check the wrapping on the top, make sure there wasn't any scratches or issues with the wrap. And also, I figured that with regular use, that those discs would not hold up. So that's when I popped them off. So the cells are freed up, they're numbered, they're ready to be tested. And if they test out good, I'll be adding them to my collection of cells for running my camera so that way I can retire the worn out cells. So anyways, hope y'all enjoyed this video. Thanks for watching.